All right, so today we're going to be continuing a look at differentiation. We have touched on some of the basics of differentiation last week, and we're going to continue with that. And then, of course, we want to go deeper into differentiation as well, right? So we looked at differentiating powers of x last week. We looked at differentiating constants. We also looked at differentiating we'll call polynomials, and we use the fact that differentiation is distributive over addition and subtraction, which basically means that if you want to differentiate the sum of two functions, then that is the same thing as finding the sum of the derivatives of the two functions. And we're able to use that in differentiating polynomials. So before I look at anything new, let's just touch on a few more examples of differentiating polynomials and a few little applications of differentiation, right? So let me see what I can write down here from my screen. So are you seeing my screen clearly? Are you seeing my screen
Yes, sir.
clearly? All right, good. All right, so let's begin with this one here. I'm going to look at number 6. So number 6 says find the gradient on the curve y equals 4x cubed minus 10x plus 1 at the point where x is equal to 1. Now, remember we said that for any function y equals f of x, dy by dx is called what is called the gradient function of the curve, right? So what dy by dx allows you to do is to find the gradient of the curve at a particular point. So when you find dy by dx for any particular curve, essentially what you're doing is finding what is called the gradient function. And if you want to find the gradient of the curve at any particular point, you simply substitute the x-coordinate of that point into the gradient function, and it will actually give you the gradient of the curve at that particular point. So let's look at this example here in number 6. So number 6, we have the equation y is equal to 4x cubed minus 10x plus 1. So y equals 4x cubed minus 10x plus 1, and we want to find the gradient at the point where x is equal to minus 1. So the first we must do is to find dy by dx. So to find dy by dx, we apply the regular rules of differentiation. We keep our multiplying constant 4, so we keep that, and we proceed to differentiate. When you differentiate x cubed, we bring the 3 down, multiply by it, reduce the power by 1, and so that gives us 3x squared, right? So 4 times 3x squared, we close our bracket. Then we come over here, we put down the minus 10, and you differentiate the power. Well, x, same thing as x to the power of 1. When you differentiate that, you simply get, well, x to the 0, which of course is the same thing as is 1. And of course, when you differentiate 1, you simply get 0. So dy by dx equals 4 times 3x squared minus 10 times 1, which of course is equal to 12x squared minus 10. So that is the gradient function. And therefore, if we want to find the gradient at the point where x is equal to minus 1, we could say that, for instance, dy by dx, draw a little line and say x is equal to minus 1. This is basically showing you that we're going to be evaluating the gradient function dy by dx at the point where x is equal to minus 1. So this, of course, will be equal to 12 times minus 1 squared minus 10, which is equal to 12 minus 10, which is equal to 2. So what this is basically telling us is that at this point on the curve, the gradient is equal to 2. Any questions?
No, sir.
All right.
No, sir.
Now, the syllabus also requires us to be able to identify the derivative as a rate of change. Now, when we have a function dy by dx, what this is basically telling us is that this is essentially the rate of change of y with respect to x. So any form of derivative essentially can be interpreted as a rate of change of one variable with respect to another. In the case of dy by dx, we're really finding is a rate of change of y with respect to x. And so some questions will involve rates of change. And of course, we'll be looking at connected rates of change later, right? So with this said, let's look at number 5. Let me just clear my screen a little bit. So number 5 says, y equals 4x squared minus mu x plus 6. So that letter there is a Greek letter mu, right, which is also used to represent micro in your list of standard multiples and submultiples. So that is a Greek letter mu, right? Now, the equation that we're given is y equals 4x squared minus mu x plus 6. And what we're told is that the rate of change of y with respect to x is 2 when x equals 1. What does this mean? It means that dy by dx is equal to 2 when x is equal to 1. And so what we're told to basically find the value of mu. So first of all, what we must do is to find dy by dx. I'm going to say that dy by dx is equal to 4. We keep on multiplying constant 4 outside, and we proceed to differentiating the powers of x. In this case, first thing we have to differentiate is x squared. When you differentiate x squared, the 2 comes down, x gets reduced by 1, the power that is, so we get 2x to the power of 1. Then, of course, mu is a multiplying constant. We keep the mu. We differentiate x with respect to x. We simply get 1. 6 is a constant. The derivative is 0. So we don't need to write plus 0. So therefore, this means that dy by dx is equal to 8x minus mu. But of course, we're given this, that dy by dx is equal to 2 when x is equal to 1. And so if we were to apply that, then essentially what we have is this. So we say that dy by dx equals 2 when x is equal to 1. And so we substitute x equals 1. So we get 8 times 1 minus mu, and that will be equal to 2. So therefore we have 8 minus mu is equal to 2. And we know that when you subtract 6 from 8, you get 2. So this clearly means that mu is equal to 6. So therefore the value of mu is equal to 6. All right? So not only should we be able to differentiate expressions to find the gradient function, we should be able to apply the gradient function or to something like finding the gradient at a particular point or using it to find some unknown constant given the gradient and the coordinate of a particular point. So that was number 5. So the next one we're going to be moving on to for now is, let me see, which one is it? I'm going to look at. All right, so let's look at number 7. Number 7 says the gradient on the curve y equals ax squared minus 3x plus 4, where x equals minus 2 is 13. Find the value of a. So this one is actually very similar to this one. So what I'm going to do is I'm going to leave you to actually try that one. So because this one is very similar, we're given a function with some unknown constant, and we're given the value of the gradient function at a particular point, and we're asked to find the value of that constant. So I want you to try number 7, right? Are you getting through?
Yes, sir.
Okay. So number 7. Number 7 says the gradient of the curve y equals ax squared minus 3x plus 4, where x equals minus 2 is 13. So begin by writing down the equation of the curve. Y is equal to ax squared minus 3x plus 4. The next step is to find dy by dx. So find dy by dx. This gives us a, or multiplying constant, we keep that. When you differentiate x squared, we get 2x. We have minus 3 times 1 plus 0. When you differentiate a constant with respect to a variable, then that result is 0. So we have dy by dx is equal to 2ax minus 3. Did anybody get that?
Yes, sir.
All right, so just update me. Who else is in the session? Tamalia, who else?
Yes, sir.
Well, who else is here? Just indicate by letting me know, right? Please.
Yes, sir. It's just two of us.
Just the two of you? Okay, all right, thanks. All right, so dy by dx equals 2ax minus 3. So what we're told in this one is that we're told that, well, the gradient on the curve where x equals minus 2 is 13. So basically what we're saying is that at x equals minus 2, dy by dx is equal to 13. And so we will use this information to find the value of a. So here goes. So we can say 2a times minus 2 minus 3 is equal to 13. So minus 4a minus 3 is equal to 13. Minus 4a is equal to 13 plus 3. Continue over here. Minus 4a is equal to 16. So a is equal to 16 divided by minus 4. So a is equal to minus 4. Did you get that?
Yes, sir. Yes, sir.
Okay, very good, very good, very good. Nice. All right, let's do another one. Let's look at number 8. Number 8 says, find the coordinates of the points on the curve y equals 3x cubed minus 4x plus 2, where the gradient is 0. So this one is a cubic expression or cubic equation, but the procedure is quite similar. We first have to find dy by dx. And they tell us that they want us to find the coordinates of the points, so plural, on the curve where the gradient is equal to 0. So when you find dy by dx, we're going to set it to 0 and we're going to solve for x. Is that clear?
Yes, sir.
So when you differentiate a cubic rather, you're going to get a quadratic. So this is number 8. So what we have is this. We have y equals x cubed minus 3x squared plus x minus 5. We differentiate. So we get dy by dx equals 3x squared. Now at this stage, I'm going to start skipping some little, some little small steps when it comes to, differentiating and, multiplying. So I'm just going to, skip those little small steps. So 3x squared minus 6x plus 1. So that is what we get for a gradient function. And we're told that we're supposed to find the coordinates of the points where the gradient is equal to 0. So what we're supposed to do is we're going to set dy by dx equals 0 and solve for x. Now, what type of equation would that be? First of all, what type of expression is this? 3x squared minus 6x plus 1. What do we call expressions like those?
A quadratic equation.
A quadratic. So a quadratic expression, and of course, when you set it to 0, you're going to get a quadratic equation, which by now you should be able to solve. Now, not all quadratic equations can be factorized, so you may have to use a quadratic formula, which by now you should be familiar with, right? So I imagine that this one cannot be factorized just by looking at the coefficients. No, I made a mistake here. Oh gosh, no, I didn't make a mistake. Sorry, I thought I made a mistake. Which question am I looking at? I'm looking at number 9. Which one am I doing? Number 8 or 9?
Number
All right.
8, I think.
All right. So I did make a little mistake because apparently I was supposed to be number 8, but then I wrote down the equation for number 1. Sorry, number 9. And number 9 is not supposed to be gradient to 0, but the gradient is supposed to be equal to 1. So let me fix this. So this is supposed to be dy by dx is equal to 1. Right, so I inadvertently tried to combine number 8 and number 9. This is what we're supposed to have. We have y equals x cubed minus 3x squared plus x minus 5. And we want to find the coordinates of the points on the curve where the gradient is 1. Right, so we're going to set dy by dx equals 1 and then solve for x. So go ahead and try that for me. Is that clear? Is it clear what you're supposed to do?
Yes, sir.
All right, good. Go ahead. Was that somebody else joining? Or did somebody got kicked out and then rejoin?
Somebody joined, sir.
Okay. That somebody. Could that somebody identify yourself, please?
Yes, sir, it's me, sir.
That's who, Kyle?
Yes, sir, it's Kyle.
You're joining so late, man.
So I have problems going on to this computer, so that's what.
All right, cool, no problem. So we continue to look at differentiation. We're looking at number 9 rather. So this is read number 9, not number 8. I inadvertently make a little mistake of trying to combine the two questions. So looking at number 9. So number 9 says, find the coordinates of the points on the curve y equals x cubed minus 3x squared plus x minus 5, where the gradient is 1. So we went ahead and differentiated and found the gradient function dy by dx. Then we say that we're supposed to set dy by dx equal to 1 and then solve for x. So everybody should be able to solve that resulting quadratic equation. You getting through?
Yes, sir.
So this one should not be a very difficult one. Okay, so you should be finishing with this one because this was not one of those quadratics where you have to apply the regular methods of solving because the ones are going to cancel. So, as I said, what we're supposed to do is we're supposed to set dy by dx equal to 1 and then solve for x. So basically what we have is this. 3x squared minus 6x plus 1 is equal to 1. Those two ones will cancel. So we can basically say that 3x squared minus 6x plus 1 minus 1 equals 0. So we have 3x squared minus 6x is equal to 0. Yes, this is a quadratic. We can factorize. The 3 is, we have 3 and 6. Highest common factor is 3. We have x and x squared, so we can factor out x. So totally we can factor out 3x, open bracket, x minus 2 is equal to 0. And so basically, we have 3x times x minus 2 equal to 0. We can say that 3x is equal to 0, which means x is equal to 0, or x minus 2 equals 0, which means x is equal to 2. Did anybody manage to get those two values? Hello?
No, sir.
What happened there? You should have
Sir,
been.
never mind.
Uh, go
Go
ahead.
ahead, sir.
Go ahead.
It's a quadratic equation.
I'm, I,
I
I
equated
mean,
it to 0. So,
well, I mean, it's a quadratic, but you should have recognized that the two ones cancel each other, subtracted. So you're basically left with an easily solvable quadratic. So yeah, you have to be aware of those little things. But the question is not finished though. They basically ask us to find the coordinates of the points on the curve. So since we found the x coordinates, we need to now go and find the y coordinates by substituting the values of x into the given equation of the curve. And so we have y equals x cubed minus 3x squared plus x minus 5. And so when x equals 0, y would be equal to minus 5. So that point, of course, is 0 minus 5. We do the same thing now, but this time when x equals 2. So we say that when x equals 2, we have y equals 2 cubed minus 3 times 2 squared plus 2 minus 5. So we have y equals 8 minus 3 times 4, which is 12, plus 2 minus 5. So this basically gives me 8 minus 12 is minus 4, plus 2 minus 5 is minus 3. So that gives me minus 7. So the other point is 2, negative 7. Right? So that is how we approach that question there. They told us that to find the coordinates of the point on the curve where the gradient is equal to 1. So we had to find dy by dx, set it equal to 1, then solve the equation for x. And having obtained or found the x values, we had to then go find the corresponding y values by substituting those x values into the original curve. Is that clear? Is that clear? Anybody there?
yes, sir, I understand now.
Yes, sir.
So that was number 9. So number 8 is very similar. So I'm going to leave this on the screen and I want you to do number 8. Right? Number 8 says find the coordinates of the points on the curve y equals 3x cubed minus 4x plus 2 where the gradient is 0. So just as we did, the first thing you're going to do is to find dy by dx. So this is your first step. Find dy by dx. Then a second step, in this case, you're going to set dy by dx to equal to 0 and then use solve for x. When you're finished solving for x, you're going to have to substitute those values of x into the equation for y, which is this right here. This is basically step 4, right? So you should be able to follow those steps and get the corresponding value of x and y at which, or the points or coordinates at which the gradient, of course, is equal to 0, all right? All right, so go ahead and do that. And of course, you must pay attention to the wording. It says find the coordinates. So that we're talking about x and y coordinates. And it says of the points. So now we're supposed to get at least 2 points because it's plural. Okay?
Yes, sir.
All right, so go ahead and try that. I'll give you a few minutes to try and do that one. Getting through?
I think so, sir.
Okay. Kyle?
Yes, sir. Yes, sir.
You getting through?
Yes, sir. I get you.
All right. What about you, Tamalia?
Yes, sir.
Okay. All right. So let me start working this one. By the time I make some headway, you should be finished. You've had some head start. All right. So this one should be number 8, not number 9. All right. So this one says, find the coordinates of the points on the curve y equals 3x cubed minus 4x plus 2, where the gradient is 0. So first of all, we're going to write down the equation of the curve. Y equals 3x cubed minus 4x plus 2. So the first thing we need to do after doing that is to find dy by dx. So we need to find dy by dx, differentiate y with respect to x. So it's going to give us 9x squared minus 4. Again, I think I could actually skip past those little steps we actually show the bringing down of the power, multiplying by it and all of that. So we can afford to skip those little steps at this stage. So dy by dx equals 9x squared minus 4. You all should have gotten that. Then the next part, notice that basically we want to find the coordinates of the point on the curve where the gradient is 0. So what we're going to do is we're going to set dy by dx equal to 0 and solve for x, right? So let's do that. So basically we have 9x squared minus 4 is equal to 0. Now, you should be able to recognize expressions of this type. Can anybody identify these type of expressions, such as 9x squared minus 4? Can anybody tell me what we call these expressions? 9x squared minus 4, x squared minus 1, 4x squared minus 25. What do we call these type of expressions? Anybody?
Sorry, was it all square? I don't remember the correct name for it.
Difference of two squares. Difference of two squares. So when we see difference of two squares, we should be able to identify them. And of course, we should be able to factorize them as well. So 9x squared minus 4 equals 0. This is the difference of two squares. This is the same thing as 3x all squared minus 2 squared equals 0. And once you can recognize that, we should be able to factorize. So this now becomes 3x minus 2 times 3x plus 2 is equal to 0. And we can proceed to solving. So we can set 3x minus 2 equals 0. So we have 3x is equal to 2. And so x is equal to 2/3. That's the first value of x. For the second value, we set the second bracket, 3x plus 2 equals 0, which means 3x is equal to negative 2. And so x is equal to minus 2/3. So these are our two values of x, but of course we're not finished. We need to find the corresponding y values because we're told to find the coordinates of the points. So, and of course, coordinates imply x and y coordinate. So what we need to do is to go back to the equation of the curve. Let's write it down. So we have y equals 3x cubed minus 4x plus 2. And we need to find the corresponding value of y when x equals 2/3 and also when x equals minus 2/3. So let's do that. So when x equals 2/3, let's do that one first. We get y equals 3 times 2/3 cubed minus 4 times 2/3 plus 2, right? So we'll try to simplify. So 2/3 cubed, that's the same thing as 3 times 8 over 27 minus 8 over 3 plus 2. And this is basically going to give us 24 over 27, which of course simplifies to give 8 over 9. So we have 8 over 9 minus 8 over 3 plus 2, which should become, competent without the use of calculator. So basically, let me just continue here. So we get 8 over 9. This is the same thing as minus 24 over 9 plus 18 over 9. And so with all our fractions having the same denominator, we can just combine the numerators. 8 minus 24, that's minus 16. Minus 16 plus 18, that is 2. So we get 2 over 9. Did anybody get that for the y value?
Yes, sir.
Okay, very good. All right, now let's do the other one now. The other one, of course, is when x is equal to minus 2/3. The same principle, just a different x coordinate. All right, so let's write this again. So we have y equals 3x cubed minus 4x plus 2. So when x equals minus 2/3, we get y equals 3 times minus 2/3 cubed minus 4 times minus 2/3 plus 2. So this time we get y equals, essentially same as before, but the sign is going to become changed. So I'll just jump to this equivalent line here. So all that has changed is a sign. So this is going to become minus 8 over 9, and this becomes plus 8 over 3 plus 2, right? So applying the same principle as I did before, this becomes y equals minus 8 over 9 plus 24 over 9 plus 18 over 9. And we can just combine the numerators. Minus 8 plus 24, that is 16. 16 plus 18, that is equal to 34 over 9. And so in terms of the points, so the points would be 2/3, 2 over 9, and minus 2/3, 34 over 9. Right? So these are the points on that curve at which a gradient is equal to 0. Any questions?
No, sir.
All right, so no questions?
No, sir.
All right, all right. So, let me see what time it is. We're more than halfway into the session. So, there's there's one other one I want you to try. Let me see which one is that. All right, I'll do number 11, and of course, I will leave you to try some of these later on, and of course, yeah, you need to get a lot of practice with these questions. So, number 11, the way it's worded will show you exactly what this means, right? So, as I'll explain many times, when you do a lot of questions, you practice, then you become exposed to the different ways that questions can actually be set. And so if you do enough questions, the odds of you seeing something entirely new become extremely smaller, right? So if you only do like a smaller number of practice questions, and of course it's quite likely when you go into an exam, you're going to see questions of a nature that you never saw before. But if you do a lot of questions, then when you go into the exam, the probability of you seeing a question that you've never seen anything of the sort before is much smaller than if you never did a lot of questions in the first place. All right, so with that said, let's look at this one, number 11. Number 11 says, show that there is only one point on the curve y equals x to the fourth minus 32x plus 10, where the gradient is 0, and find its coordinates. So this one, of course, is a quartic equation. The highest power is, of course, 4. So it will take some doing. So let's look at this one. We have y is equal to x to the fourth minus 32x plus 10, right? So show that there is only one point on the curve y equals x to the fourth minus 32x plus 10, where the gradient is 0 and find its coordinates. So if we're talking about, polynomials here, and we see gradient is 0, want to see that expression gradient is 0, then this automatically means that the derivative is equal to 0. And in this case, we're talking about dy by dx. So first of all, let's go ahead and find dy by dx. So we say that dy by dx is equal to 4x cubed minus 32, right? So simple cubic equation there. And of course, say that when the gradient is equal to 0, so gradient equals 0, of course, implies that dy by dx is equal to 0. So we're going to set dy by dx to 0, and then we're going to try to solve. So work with me. We have 4x cubed minus 32 is equal to 0. What is the HCF of 4 and 32? What is the highest common factor of 4 and 32?
4, sir.
Yeah, nobody should be struggling with this type of question. This is a regular second form math question. So 4x cubed minus 32 equal to 0. So here we can actually divide through by 2. That is not going to affect the equation, right? So but to simplify it, we can actually divide through by 4 rather, not 2. So the HCF of 4 and 32 is 4. So first of all, let me just factor out 4 first. So we get x cubed minus 8 is equal to 0. We can just divide through by 4 now. And this means that x cubed minus 8 is equal to 0. Now, probably at this level, well, you have done factor theorem. And I would have mentioned before that whenever you do a particular topic in any subject, especially so in advanced, you cannot just forget about it because it may come back in subsequent topics. So here we are looking at differentiation, and we've seen that we end up with a polynomial that we need to factorize. And to do that, we need to draw on our knowledge of factor theorem. So we're going to do that, right? So first of all, what we're going to say is, we're going to say let me just call, let's say, f of x is equal to x cubed minus 8. Now, whenever you want to factorize a polynomial, and you're not given an actual factor, you tend to examine the constant term. In this case, a constant term is equal to minus 8, and the factors of negative 8 are plus or minus 1, plus or minus 2, plus or minus 4, and of course, plus or minus 8. So we start off by evaluating a small factor, but of course, to me, the one I need is rather obvious. I'm going to jump straight to that one. So I'm going to say, so f of x equals that. I'm going to say f of 2 is equal to 2 cubed minus 8, which of course is equal to 8 minus 8, which of course is equal to 0. And because f of 2 equals 0, then this basically implies that x minus 2 is a factor of f of x, right? So because f of 2 equals 0, then according to the factor theorem, x minus 2 is a factor of f of x. Now this is a cubic equation or cubic expression, x cubed minus 8. If x minus 2 is a factor, then what this basically means is that x minus 2 will divide into that exactly. That is without leaving a remainder. So I need to find the other factor. And to find the other factor, I will use long division, right? So work with me now. So let's do some long division. So I'm going to draw my long division sign, put my polynomial inside the bracket. But what I'm going to do is, for the purpose of addition, I'm going to introduce some dummy terms. There's no x squared term. I'm just going to put plus 0x squared plus 0x minus 8, right? So that when I have to subtract some of these terms, if I have to subtract some of these terms, then we can see, let's see what they're going to give us. So here we're going to divide through by x minus 2. So even though we're dividing by x minus 2, we're actually going to carry out division by x. So work with me, right? So let me just erase it at the bottom of the screen here. So what are we going to say? We're going to say x into x cubed goes what? When I divide x into x cubed, what does that give us? That gives us x squared, good? So this gives us x squared. And then we say x squared times x is x cubed, and x squared times minus 2 is minus 2x squared. We draw a line, and of course we're going to be subtracting that. When you subtract that, the signs obviously are going to change. That becomes minus, that becomes plus. These two will cancel. So x cubed minus x cubed, those disappear. And so we have 0x squared plus 2x squared. So we have 2x squared, right? Normally, we carry down a term, but this is just 0, so we don't need to carry down a 0, right? So next we're going to say x into 2x squared. That goes plus 2x. Then we say 2x times x is 2x squared. For the purpose, I can just put the plus 0x here. Just as a placeholder. Then we say 2x times minus 2 is minus 4x. We draw a line once again, and now we're going to subtract, right? So we're going to subtract. Put our minus sign, so that becomes a minus basically. This becomes a plus. These two cancel. We get plus 4x. And then now we can actually bring down.
Sir.
Yes.
How did we get the 4x again?
We're subtracting. So whenever we're subtracting, the signs must change. So we're minus, this becomes a minus 2x squared. This is already minus, so it becomes minus 4x, which is plus 4x. You understand?
Yes, sir.
So for that line there, what we're doing is this. We're basically saying 0x minus 4x, which of course is 0x plus 4x. Okay?
Yes, sir.
Good. So we bring down the minus 8, and then we can say now x into 4x, that gives us plus 4. So x into 4x is plus 4. Then we say 4 times x is 4x. 4 times minus 2 is minus 8. Those two will subtract to leave a remainder of 0, which of course tells us that x minus 2 goes into the cubic polynomial exactly, leaving 0 remainder. So what we can do now is to say this. So we can now say that, so what this implies is that x cubed minus 8 would be equivalent to x minus 2 times x squared plus 2x plus 4, right? But remember, the purpose of all of this was to actually find the point where dy by dx equals 0. So because x cubed is equal to all of that, we can say that x cubed minus 8 equals 0. So we have x minus 2 bracket x squared plus 2x plus 4 equals 0. So we already established that x is equal to 2 because f of 2 was actually equal to 0, right? So see it right here? F of 2 equals 0, which means that x minus 2 is a factor, which of course means x equals 2 is a root. So but we can just do it again, right? Just for emphasis. So x minus 2 equals 0. So x equals 2. Or x squared plus 2x plus 4 equals 0. Now, before we proceed any further, let's just take back a look at the question and what the question really had said. The question said that we're supposed to show that there is only one point on the curve y equals x cubed minus 32x plus 10, where the gradient is 0, and find its coordinates. So we already found the x coordinate of one such point, which is x equals 2. But that is not sufficient to show that there's only one point. Another point can obviously come from this equation, but before we can actually determine that, we'll have to solve this equation. So if we're only supposed to get one point, it means that this quadratic is going to have no real roots, right? So if we're only supposed to get one point on the curve where the gradient is equal to 0, and we already found one such x coordinate, it basically suggests that this quadratic is supposed to have no real roots, but we'll have to verify that, right? So no real roots. So first of all, for this quadratic, we see that a is equal to 1, b is equal to 2, and c is equal to 4. So therefore, our discriminant, b squared minus 4ac, is equal to 2 squared minus 4 times 1 times 4, where of course is equal to 4 minus 16, which is equal to negative 12. So, what is the implication of this discriminant being negative? Who can tell me that? Since the discriminant is negative, what does that say about the quadratic?
It only has one factor.
No, no, listen to my question carefully. Since the discriminant of the quadratic is negative, what does that say about the quadratic itself? When the discriminant of a quadratic is negative, what does that say about the quadratic? This is something you should know. You do it in both regular CSET maths and add maths. If the discriminant is negative, then that means the quadratic has no real roots. And I would have I even have it on the screen already. It's supposed to have no real roots. So because the discriminant is negative, that means that this quadratic, x squared plus 2x plus 4 equals 0, has no real roots, just as I would have suspected. And so therefore, the only root that we get is x equals 2. And as such, there's only one point on the curve at which dy by dx equals 0. And the x coordinate of that point is 2. So now we need to go and find the y coordinate. Right? So because this quadratic has no real roots, it means that there's only one point on the curve at which a gradient is equal to 0. And that point occurs where x equals 2. But now we must find the corresponding y coordinate by substituting into the original equation, which of course is this right here. Y equals x to the fourth minus 32x plus 10, right? So we say that y equals x to the fourth, and write it in white. So y equals x to the fourth minus 32x plus 10. So when x equals 2, y is equal to 2 to the fourth minus 32 times 2 plus 10. So y equals 16 minus 64 plus 10. 16 minus 64, that's minus 48. Minus 48 plus 10, that's minus 38. So y is equal to minus 38, which means that the point is 2 minus 38. So by virtue of showing that the quadratic here has no real roots, it means that there's only one solution to that equation, and therefore only one point on the curve at which a gradient is equal to 0. You have to be able to analyze these questions and decipher and, figure out exactly what is being asked and do it. So, I mean, some things I expect you to know, you clearly don't remember because I know you'd have done them in school. Discriminant of a quadratic. What you use the discriminant to do? You use the discriminant of a quadratic to determine the nature of the roots, even without finding the roots themselves. So, let me just drag your memory a little bit. Generally, for any quadratic we have, ax squared plus bx plus c is equal to 0. And of course, we have the quadratic formula, x is equal to minus b plus or minus root of b squared minus 4ac all over 2a. Now, we say that, of course, when the discriminant b is equal to 0, so the discriminant d is equal to b squared minus 4ac. So if d is greater than 0, then the quadratic has real distinct roots. However, if d is equal to 0, it has what we call equal or repeated roots. So real distinct roots, of course, means that the quadratic will cut the x-axis twice, right, at two distinct points. Equal or repeated roots basically means that the quadratic is going to just touch the x-axis. So basically it's a tangent, or the x-axis is a tangent to the curve, right? And of course, d being less than 0, because you can't find the square root of a negative number, or we say that the square root of a negative number is not real, then this of course implies that the quadratic has no real roots. Now bear in mind, we did not say it has no roots. We say it has no real roots because for those of you who may move on to doing pure maths at the CAPE level, you'll be introduced to something called complex numbers. and then you will be able to find the complex roots of such a quadratic. But for now, we just say it has no real roots. Is that clear?
Yes, sir.
So yeah. All right. So I think I'm going to stop with those ones here and proceed with the other things I need to do. So we need to look at differentiating composite functions and applying the chain rule of differentiation. We need to look at the product rule, quotient rule, all of those things as well. So we need to so move on from there. All right. So I'm going to move on to look at the chain rule. I'm going to stay on this page right here because I have some questions on this page I want to be able to look at. So, I mean, maths is not a subject you can just sit down and memorize a problem. No, you have to be able to be able to read a question, analyze, and analyze the situation and apply your knowledge, to doing the question. It takes a lot of practice, and I could, as I've mentioned to you many times, maths at CSEC level is far more challenging than some of the subjects that many people have traditionally thought to be hard, like physics. It's definitely more challenging than physics. And in the exam, for instance, you have to do a lot more for the same few marks as you would do in a physics exam. So it definitely needs a lot of practice. All right, so we're gonna start looking at the chain rule. So we're gonna look at differentiating composite functions and the chain rule. I would have mentioned to you that I did this with the other group of students in Cayman, but for some reason I'm not able to access the recordings because I would have done it on a different computer. So I'll have to do them again. But when we do catch up, I'm going to be relying on you to watch those recordings so we can actually move a lot faster and get a lot more accomplished. Since I would have recently done the same thing that I'm teaching you because they're following the same syllabus, right? The same CSEC AdMath syllabus. All right, so we're going to look at differentiating composite functions, the chain rule. So differentiating composite functions. Right. Now, suppose we have something like this we want to differentiate. Suppose you have this y is equal to x minus 2 squared. Now, as it stands, we did not learn how to differentiate these directly. What we learned was how to basically expand the brackets and treat it as a polynomial. So let's do that. Now, as I mentioned, expanding the brackets here, I mean, I know that many students at this level are still having problem with expanding a binomial because all they're going to be doing is writing down that this is equal to x squared minus 4, which obviously is incorrect. Incorrect worst at its best is incomplete. When you have a binomial like this, you must multiply each term in one bracket by each term in the next bracket. If you're going to be taking shortcut, then you not only should square the first term, square the second term, but you should also multiply them twice. So you're going to say x times 2 is 2x. You multiply that by 2, so you get minus 4x, or that would normally go in the middle. So this becomes x squared minus 4x. Sorry, this should be plus 4 rather. Plus 4. So x squared minus 4x plus 4. So having expanded the brackets to present it in the form of a polynomial, we can then proceed to differentiating. So we can say y is equal to x squared minus 4x plus 4. And so dy by dx equals, when we differentiate x squared, we simply get 2x. When we differentiate minus 4x, we get minus 4. The plus 4 is a constant, which of course when differentiated gives nothing. So dy by dx equals 2x minus 4. So we see that we're able to differentiate this function by first expanding the brackets. However, suppose we have this instead. Suppose we have y equals x minus 2 to the power of 10. Would that approach work? Or, I mean, would it be I mean, it could work, but what would be the problem with trying that approach by expanding the brackets? What would be the issue if you were to try to expand the brackets in this one? Y equals x minus 2 to the 10. as opposed to y equals x minus 2 squared. What problem would we have? Anybody?
So we take a longer time.
Will take a much longer time because the power is much larger. So in this particular case, if we were to expand out the bracket x minus 2 to the power of 10, it will take us a very long time, and during that process, we are more likely to actually make a mistake. So therefore, for expressions like these with such large powers, the method of expanding the brackets would simply be too time consuming. And for expressions like these, we introduce the chain rule, right? So we introduce the chain rule. So as I said before, for expressions like these, to expand the brackets will be too time consuming, and therefore we introduce the chain rule. So according to the chain rule, this is basically the chain rule. You can say that dy by dx is equal to dy by du times du by dx. Now, this by itself doesn't really mean much, but don't worry, we'll be applying it shortly. So this is basically what the chain rule says. Now, how do we apply the chain rule? In this particular case, for instance, we could come and say, we're going to do a substitution. Let u equals x minus 2. Now, if u equals x minus 2, then this simply means that y equals u to the power of 10, right? So u equals x minus 2, which means that y equals u to the power of 10. Then, of course, you can now say that du by dx is equal to 1. And over here as well, we can say that dy by du equals 10 times u to the power of 9. You with me so far?
Yes, sir.
Right? But of course, according to the chain rule, we can say that according to the chain rule, dy by dx equals dy by du times du by dx. So we write that dy by dx is equal to, now dy by du is this, 10u to the 9. So it becomes 10u to the power of 9 times du by dx, which of course is 1. So this simply gives us 10 times u to the power of 9. Right? However, we're not finished because the original problem was given in terms of x, and we made the substitution that u is equal to x minus 2. So we must now reverse that. Reverse that substitution, and so say that this is equal to 10 bracket x minus 2 to the power of 9. So that is an example of how we apply the chain rule to differentiate composite functions. Any questions?
No, sir.
All right, let's look at some examples of applying the chain rule from this exercise here. So we're going to start with, let me start with I'm going to do the odd numbered ones. Should I do odd numbers or even numbers? Well, actually they're not numbers, but they're letters. But anyways, let's start with B. So B, we have y equals 3x minus 1 to the power of 7. So we recognize that this is a composite function. How? Because 3x minus 1 is a function of x. By raising that to a power 7, it becomes a function of a function and hence a composite function. Is that clear?
Can you repeat once more, sir? Can you repeat that once more?
So this is a composite function because it is basically a function of x. 3x minus 1 is indeed a function of x. And by raising that entire thing to the power of 7, then we basically have a function of x, and therefore this is a composite function. And being a composite function means that we can apply the chain rule to differentiate it. So what are we going to substitute? We're going to say let u equals 3x minus 1. Now, if u equals 3x minus 1, then what this basically means is that y equals u to the power of 7. And also we can say that du by dx is equal to 3 times 1, which of course is equal to 3. We can also come over here and say that dy by du is equal to 7 times u to the power of 6. Okay?
Yes, sir.
So we can now come and say by the chain rule, dy by dx is equal to dy by du times du by dx, right? So what does this give us? Dy by dx is equal to 7u to the power of 6 times du by dx, which of course is equal to 3, which gives us 21 u to the power of 6. But of course, u is equal to 3x minus 1. So therefore, what this means is that dy by dx is equal to 21 times 3x minus 1 to the power of 6. And that is it right there. That is the derivative of 3x minus 1 to the power of 7 using the chain rule. Mm. Any questions?
No, sir.
So let's do a few more. So that was B of that question there. Let me do C and D. Then of course I'll ask you to I'll should I do both C and D? No. I will do a next one. And then I'll ask you to try one. Let me do C. 5 minus 2x to the cube. 5 minus 2x to the. Alright, so C says 5 minus 2x cubed. So let's write it as y equals 5 minus 2x cubed. So we should be able to recognize that this is a composite function. 5 minus 2x is a function of x. And by raising all of that to the power of 3, it becomes a function of x, and therefore a composite function. So right away, we're going to say that let u equals 5 minus 2x. Now, if u equals 5 minus 2x, then this basically means that y is equal to u cubed. And then you can proceed to differentiating. So dy by dx, sorry, this should be du. So du by dx is equal to minus 2. 5 is a constant. The power of x there is 1. The coefficient is minus 2. So du by dx is equal to minus 2. Right? Now, over here, now we can say that dy by du equals 3u squared. Again, we bring the power down, reduce the power by 1, and then, of course, well, multiply by the power, reduce the power by 1. So dy by du equals 3u squared. And again, by the chain rule, we say that dy by dx is equal to dy by du times du by dx. Right? So do we have those things there? I think we do. So therefore, this is going to give me that dy by dx is equal to, what is dy by du? This is 3u squared times du by dx, of course, is minus 2. So this becomes minus 6u squared. But of course, u is equal to 5 minus 2x. So this, of course, same thing as minus 6 bracket 5 minus 2x squared. Right? So that is this one here. So dy by dx is equal to minus 6 open bracket 5 minus 2x all squared. Any questions?
So could I go over d over dx?
What do you mean? Go over what exactly?
Or you got negative 2.
What do you mean? We differentiate 5 minus 2x.
Oh, okay, sorry.
There's only one x term. 5 is a constant. The multiplying constant there is minus 2. So differentiate x to the power of 0 or 1. So this just becomes minus 2. At this level, you should be able to, at this stage, you should be able to see those are derivatives because, you have far more complicated things to be worried about. So you should grasp these things, without having to explain those little steps. So differentiate x, you get x to the 0 or it's a constant 1. And if there's a multiplying constant in front of that, of course, you keep on multiplying constant. All right?
Yes, sir.
All right, so I want you now to try D. So D, write it as y equals 4x minus 5 to the power of 10. So first of all, of course, you're going to let u be equal to 4x minus 5. Find du by dx, similar to what I did here. So for instance, so write down the problem. Y is equal to 4x minus 5 to the power of 10. And try applying the chain rule by first making your substitution. All right, are you getting through?
Yes, sir.
I'm okay.
Yes, sir. Did you come?
You finished?
Yes, sir.
All right, so let me go through this one. All right, so which one is that second? It was a D. It was D, right? Y equals 4x minus 5 to the power of
Yes,
10.
sir. D.
All right, so y equals 4x minus 5 to the power of 10. So we're going to say let u equals 4x minus 5. And this, of course, means that du by dx is simply equal to 4 times 1, which, of course, is equal to 4. Now, if u is equal to 4x minus 5, then this further implies that y equals u to the power of 10. And dy by du is equal to 10 u to the power of 9. And so, I mean, we can actually go ahead and make the substitution right here. So we can go back and say that dy by du would actually be equal to 10 times 4x minus 5 to the power of 9. We can do it from here. And so now we can use a chain rule and say that dy by dx is equal to dy by du times du by dx. And so, therefore, dy by dx is equal to 10 times 4x minus 5 to the 9 times dy by du, which is 4. And so this gives us 40 bracket 4x minus 5 to the power of 9. Did you get that?
Yes, sir.
All right, good. Right. All right, so go ahead and do E. E says, let E be y equals 4x minus 3 to the power of 4. Now, after you finish E, I will actually show you a shorter way of doing the chain rule, but of course, it's essentially the same thing. All right, getting through?
Yes, sir.
Yes, sir.
Okay. All right, so let's look at this one. And of course, I'll show you a shorter way now to look at the chain rule without having to go through those substitutions, but of course, all right, it's almost time. So here we have y equals 4x minus 3 all to the power of 4. Oh, let me start. All right. So, as customary, we say that let u equals 4x minus 3, which means that du by dx is equal to 4 times 1, which gives us 4. And of course, this would also mean that y equals u to the power of 4. And so we say that dy by du is equal to 4u cubed. So we can come over here and say by the chain rule, dy by dx is equal to dy by du times du by dx. So this would give us dy by dx is equal to 4u cubed times 4, which gives us 16u cubed. But the original problem was not given in terms of u, it's given in terms of x. And so we must resubstitute for u. And so this will actually give us 16 times 4x minus 3 to the power of 3. Did you get that?
Yes, sir.
All right, good. All right, so let me show you now the quick way of applying the chain rule, because when you're doing this exam, nobody expects to making those multiple steps and those substitution. That will take up a lot of time. So I'm just going to do a few of the same ones that we did before, but I'm going to do them the much quicker way, right? Same principle, same procedure really, just a slightly quicker method. But essentially works out with the same thing without having to make the substitution. But I would have introduced it like that for you to get a good grasp of it. And once you get a good grasp, you can now basically look at the less time consuming method of applying the chain rule. All right, so look at same few ones that we looked at. So for instance, we're going to start with B. So we're going to say y equals 3x minus 1 to the power of 7. So pay close attention now. I'm just going to say dy by dx equals. Now the first, I'm going to treat this like a regular power of x. I'm going to bring the power down, multiply by it, then reduce the power by 1. So it becomes 7 brackets 3x minus 1 to the power of 6. So that is the first part. But because it is a composite function, I have to multiply by the derivative of what is inside the bracket, which is 3x minus 1. Now, if you're wondering, then this would have been the same step that would have done. So this little piece right here would have been my finding my du by dx. And this little piece right here would have been basically finding my dy by finding my dy by du, basically, yeah. So it essentially gives the same thing. And so basically what this is going to give is that we have 7 times 3x minus 1 to the power of 6 times 3, which gives 21 times 3x minus 1 to the power of 6. Same thing got from before. Another one. Let's look at C. Change the color here. C. So we have y equals 5 minus 2x cubed. We can say that dy by dx is equal to, first thing we do, we bring the power down, write back the 5 minus 2x, reduce the power by 1, but because it is composite, we have to multiply by the derivative of 5 minus 2x, which of course is what is inside the brackets. And so this gives us 3 times 5 minus 2x squared times negative 2. And so this gives us minus 6 times 5 minus 2x squared. And of course, you simply cannot multiply through the 5 minus 2x by the negative 6 because this is being squared. Okay? So you therefore cannot say that it's going to be equal to minus 30 plus 12x squared. No, that is absolute madness. Okay? So right, that was the next one there. So let me do one more now. We apply the quick method. Try to search again. So let me do D. In D, all right. So let me look at D. D basically of the form, well, y equals 4x minus 5 to the power of 10. So say y equals 4x minus 5 to the power of 10. So we say that dy by dx is equal to, we bring the power down, 10, multiply by it, reduce the power by 1, then multiply by the derivative of what is inside the brackets, d by dx of 4x minus 5. And so this becomes 10 times 4x minus 5 to the power of 9 times 4, which gives us 40 times 4x minus 5 to the power of 9. Right? So that is the quick way of applying the chain rule. Right? So we managed to look at the chain rule. Next week, we want to continue looking at the product rule, quotient rule, and of course, some further applications of differentiation. I implore you to watch the recording, catch up on anything that you might have missed. I will check those previous recordings at other group of students to see if the ones that are available are for ears that you could actually follow and actually pick up, and I will let you know in the WhatsApp group. Okay.
Yes, sir.
Yes, sir.
So we'll end the session there and we'll meet again next week.
Yes, sir.
All right. Take care.